All right, so this is Algebra 1, lesson 9-9. Today's date is Wednesday, March 25th, 3/25. Yeah, we're factoring perfect squares today. We were factoring a difference of squares yesterday. So is there a yes in the nonverbal feedback that wants to read the objective? Again, a quiet raised hand is for a question. A yes is just to participate. So is there anyone that has a yes that wants to read our objective? No one. I guess we're just copying it down. And just for the sake of giving you guys time, I can read the objective. And I'm like battling with Riley so that he doesn't slap the laptop. Riley.
Looking at a black screen.
Hello.
Our objective today is to factor perfect quadratics of the form a squared plus 2ab plus b squared. Sorry about that. I know that Wyatt raised his hand, but I missed it. I'll get you next time. So this is a review from a previous lesson. If I have the quantity of a plus b and I'm squaring that, do you guys remember what that's equal to? And if not, that's okay, because we can multiply this out to figure it out eventually either way. Oh, yeah. Wyatt?
Would a plus b to the power of 2 just be a squared plus b squared?
It is actually not a squared plus b squared, and I'm glad that you actually made that mistake because I get to talk about it now. Here, go play with Mama, bud. Go play with Mama. I'm trying to teach a lesson. You're in the way. A squared plus b squared. Those are two of the terms, but there's a middle term that most people forget about. I know.
Oh, yeah.
So where does that middle term come from? If I have a and then plus b, and then the other side is also a plus b. Let's go ahead and multiply this thing throughout. So, yeah, Emma, you have a question?
No, but I know what the answer is that goes in the middle.
Oh, okay. Yeah. So if you have an answer, if you just want to put a yes, we're gonna actually go ahead and derive that for how we got that thing in the middle. So Charles, what goes in the top left?
Oh, could I say the shortcut?
Okay, yeah, you can say the shortcut.
It's the square the first, double the product, multiply the last.
Or square the last.
So you would, square the last. So it would be a times b. So it would be 2ab.
A times b is exactly the product, and then you double the product.
And then you double it.
I'd say no.
Yeah. Cool, thank you. And then in terms of where does this come from, let's go ahead and rederive it really quickly. So a times a in this cell right here. Emma, do you have that?
No, yeah.
A squared.
It is indeed a squared. Yep. Thank you. Wyatt, what about the top right squared? A times b.
Baby.
Someone new. What goes in the bottom left of our general rectangle? Ugo?
AB.
AB again. Yep, thank you. What about the bottom right? Theoretically, someone that hasn't participated yet. Otherwise, on a cold call. Yeah, Jade?
2b or b squared.
It is indeed b squared. Perfect. Yeah, and then the like terms usually occur in these diagonals, and that is indeed the case. We have ab and ab, which are the same term. They're the same variables to the same powers. It's a to the power of 1, b to the power of 1, a to the power of 1, b to the power of 1. So it's the same letters, the same variables, the same exponents, the same powers. Therefore, they're like terms. I add one AB with another AB, and I get a total of 2 AB. So that's where that came from. All right. So the hardest part in terms of using the shortcut today is knowing that you can even use the shortcut. Like, how do I know if I have a perfect square? And the answer is difficult. And that's why I also added a part in the notes down here that says, oh, also clear these hands, that says one method that always works in case you don't want to memorize a shortcut. It's the same thing that I talked about yesterday, but I'll talk about it again today. So Fourth, x squared plus 12x plus 9 is a perfect square.
My
But
fingers
how did
seem
I know
hard.
that? I know that because I can check by doing this in words. And I'll tell you what to write down here. You're going to take the square root.
I'm gonna read this book.
Okay.
Thank you.
Okay.
I'm going to take the square root
Okay, I'm gonna.
of the first term, and then I'm going to multiply that by the square root again. Of the last term, and I'm going to multiply those two square roots by 2. If that is the middle term, then I have a perfect square. So I'll let you copy that down in words, give you guys another 10 seconds or so. And then I'm going to work on actually applying this to verify that I have a perfect square.
So we're undoing.
Say again?
So we're undoing what we did before.
Exactly, yeah. And
Oh.
if this method sounds convoluted and difficult, then again, I'll be showing you something that always works that you don't have to memorize all this special math. Yeah, what?
So to get that middle term of the doubled the product, you're square rooting the first, square rooting the last, and doubling it to get your product.
Yeah, it's very similar to like a reverse, like rocking the baby to sleep type of thing. I agree. Yeah, so let's go ahead and check this. So I'm going to write this out. The square root of the first. So the square root of the first, well, the first is 4x squared. And I'm going to multiply that by the square root of the last, so square root of 9. And I'm going to multiply that by 2. And by the way, this is all supposed to be happening in our heads. I'm assuming now you can take the square root of 9 in your head. It might be a little bit harder to take the square root of 4x squared in your head, but I'm hoping that you see that it's 2x. So I say, okay, square root of 4x squared, and I gave the answer away. It's 2x. So I'm taking the square root of 4, which is 2. The square root of x squared is x.
Oh, so that's 12x. Wait, so is 12x the answer?
So I'm just checking, is that the middle term? Do I get the middle term?
Oh, okay. Yes, okay.
So I have 2x times the square root of 9, 3 times 2. So if I multiply these all together, well, 2 times 3 is 6, and then 6 times 2 is 12, and I don't forget about the x. So I have 12x, which indeed, 12x. And I have to verify, does this match the middle term right here? And I give myself, yeah, check, it does. If you get a check here, if that is true, then you have a perfect square. So every time that I see a polynomial, I'm doing this in my head. I'm taking the square of the first, the square of the last really quickly. I'm doubling that, and I'm seeing, is that equal to the middle term? If it's not equal to the middle term, I have to use a different strategy. But if it does equal the middle term, there's a really, really quick way of writing the answer. And it's you take the square root of the first plus the square root of the last. That's essentially what this is saying, because I have the square root of a squared is a, the square root of b squared is b, and I just add those together. So let's go ahead and do that now. So now that I have verified that this problem is a perfect square, I'm going to take the square root of the first, which I've already done, plus the square root of the last, and add those together. So essentially, I'm doing this line right here, but a plus sign and square it. So 2x plus 3 quantity squared, done. I have now factored 4x squared plus 12x plus 9. It is 2x plus 3 quantity squared.
Okay.
So I'm going to go through that process once again, because this is the hardest part of the lesson. The question that we're asking is, how do you know if you have a perfect square? How do you know that this thing I can use a shortcut on? So if I take the square root of the first, the square root of the last, and I double those, so that's what I'm doing over here. I'm taking the square root of the first, the square root of the last, and I'm doubling that. If those multiply to the middle term, which it does in this case, then I have a perfect square that I can apply the shortcut to. So what is the shortcut? Well, we've already listed the shortcut. The shortcut is up here. The shortcut says, hey, if I have something in the form a squared plus 2ab plus b squared, just take the square root of the first, the square root of the last, that will turn into A, that'll turn into B. Add them together, put them inside the parentheses, square it, that's a perfect square.
So what you're doing right now is just making sure it's a perfect square.
All I'm doing is verifying it's a perfect square, and very briefly, I'm showing you the shortcut is, yeah, square root of the first, square root of the last, put it inside of a perfect square.
Okay.
And that's what we did down here. So how do I actually factor this thing now that I know that I can apply the shortcut? Well, I took the square root of the first, which was 2x, the square root of the last, which was positive 3, and I put it inside of this parentheses squared, and that is how you factor that perfect square. Yeah, question, Wyatt. Oh, Wyatt, do you have a question?
I think Wyatt's on mute and he doesn't know it.
Squared.
Oh, sorry. Say
You were on mute that whole time, Wyatt.
Mr. Siddell, what's 2x plus 3 squared? What's that equation called? Just a perfect square.
perfect square. Yeah, exactly.
Okay.
Or if you want to be a little bit more official, it's a binomial square or a linear binomial square.
Okay.
All right, so that's the shortcut. I've taught you the shortcut, but I want to show you something just in case you don't want to memorize all of these shortcuts. And there are, a lot of different tricks that you can use in mathematics. I'm showing you those tricks, but I'm also going to show you one method that will work for everything. And that method is the Advanced Ninja Star. For all of Algebra 1, if you don't know what to do and you're a master of the Advanced Ninja Star, you will get 100% because the Advanced Ninja Star is that hammer that I can hammer every single problem. It's a blunt tool that works, but it sometimes takes a little bit longer than if I knew the shortcut. So let's use the Advanced Ninja Star on that same problem and we'll get the same answer. So again, let's review our 2 steps whenever we are factoring. Is there someone that can give me a yes in the nonverbal feedback? What is always going to be the first step? The first step is always, always, always Kira.
You got to find the GCF, I think.
Find the greatest common factor and then factor that out. Exactly. Yeah, thank you. So for this right here, I have a 4 and a 9. There's like those are called, what are they called?
Coefficients.
There's a
Do it.
term that I'm trying to think of where they're both, oh man, I'll remember at the end of the lesson, but they can't, there's no greatest common factor between 4 and 9. There's nothing that I can factor out of 9 aside from 1, 3, and 9. And 1, 3, and 9, the only thing that goes into those is 1 for 4. So there's nothing that I can factor out. So step 1, check. There's no greatest common factor. I'm on to step 2, which is Advanced Ninja Star. I told you guys that there's always 2 steps. If you follow those 2 steps, you will always get the right answer. Greatest common factor, Advanced Ninja Star. So we are now on the second step, Advanced Ninja Star. Is there someone that can give me a yes in the feedback, the nonverbal feedback, to tell me how to set up my Advanced Ninja Star? And theoretically, I want to be calling on someone that hasn't participated yet today. Yeah, Ulysses. And then Larissa has a question after that, I think. Yeah, Ulysses, go for it.
Would you do 4 times 9?
Yep, 4
at
times
the
9,
top?
which is
4 times 9, 36.
perfect. Yep, 36 at the top. Keep going.
And then 12 at the bottom.
I agree. Yep.
And then 4x on like the sides.
Works in the top right, in the top left. Oop, I don't know why I wrote a 2x there. Yes, precisely. Yeah, thank you. All right, so Ulysses will set up our Advanced Ninja Star.
Yeah. I figured it out.
Oh, okay.
Wait, Mr. Sindel, I have a question.
Yeah, so you have like the raised hand. Go for it.
Up there you were doing like how to tell if you have a perfect square, but you found an answer from that. Is that also like a way to solve it?
So the answer to factoring this is 2x to the plus 3 to the power of 2. This is how to factor it. And again, the answer here is this. I don't know if I'm answering your question, but this is the equivalent of 2x plus 3 times 2x plus 3. Am I still? Maybe you can ask your question a different way.
Well, so that method right there, square root of the first term times square root of the last term times 2. That's how you tell if you have a perfect square. But
Yes.
is that also a way to get an answer?
So the
Because
way.
you got an answer.
Okay, I understand the question now. Yeah, thank you. So the way that you get the answer is on this first line up here. If you verify that it is this form, well, all we're verifying with those steps is, do I get 2ab there? If you verify that, then in order to get from this right side to the left side of the equal sign, I have to get a. To get a, I'm going to take the square root of the first term. I have to get b, which means I'm taking the square root of the last term. And then I just kind of plug it in and make it look like this form of a plus b quantity squared.
Oh, I see.
Yeah, that was a great question. All right. So I'm assuming that people that still have yeses are ready to participate and solve this advanced Ninja Star now. Again, our question is, what times what is 36? That's the first question. And then after that, those two numbers have to add to 12 also. Charles, you have a question?
Yeah. So in this format, when it's like a perfect square, will
Yes.
it always be what that perfect square roots to? As the answers on the bottom?
So are you talking about the
Like
advanced
in
Ninja
this,
Star, or are you talking about?
on the advanced Ninja Star, yeah.
Yeah, so the perfect square, I guess I'm still not understanding. Are you talking about the 12 in the bottom?
No, the 36.
Oh, are you asking, is
And the
it always
12.
going to be a perfect square?
So like the answers on the sides, will it always be the square rooted?
Yes, it will
Like
be.
in this case, it would be 6.
So the answer is 6 and 6, and that means that it is a perfect square. So I guess another way of answering your question in a different form or a different wrapper is, if you do an advanced Ninja Star and you get the same number here and the same number here, you could have used the shortcut for perfect squares, because this, by definition now, is a perfect square. This is a side of the square. This is a side of the square. We have to reduce the fractions, of course, still, and those are the same. Therefore, it is by definition a square. If I have a length times another length that's perpendicular, that is a square.
So the advanced Ninja Star works for perfect squares and for non-perfect squares?
Advanced Ninja Star works for every single quadratic that we're going to be dealing with in Algebra 1.
Okay.
All right. I'm still not done with the advanced Ninja Star. So Charles told us that the answer is 6 and 6, because 6 plus 6 adds to 12, and 6 times 6 multiplies to 36. What do I do now? What's the next step for advanced Ninja Star? Asha?
Now you have to divide the fraction. So I divided both fractions by 2, and I got 2x over 3 for both of them. So I got 2x plus 3 in parentheses, 2x plus 3 in parentheses.
Yeah, perfect. Which is the equivalent of saying this thing right here, 2x plus 3 quantity squared. So I'll go ahead and do arrows both ways that say these are the same answer. So I'm not 100% sure, but I'm pretty sure both of these would be correct on Khan Academy. If you want to save a little bit of typing, you should probably do the one with a square in it instead of typing it twice. But I'm pretty sure both of them will give you the correct answer. I mean, mathematically, they're both correct in my eyes. All right. So that is the end of me teaching you things, but I want to practice how to do those. So the first 3 examples are the first assignment, and then the last 3 examples are the second assignment, where it gets kind of harder. Like, whoa, that looks really hard. 72, 24, and 8. Those are big numbers. All right, so let's start with baby steps. Here you go. We're on example number 1. Again, if you have a yes in the nonverbal feedback, I assume that you're ready to go. Eventually, I will hear from everyone, but I'll give this to maybe someone again. Being the first at tackling a new problem is a little bit difficult. All right, so we have x squared plus 12x plus 36. First, I will verify for you that it is a perfect square. you should probably assume, oh, this is a lesson on perfect squares, and you gave me an example. I hope it's a perfect square, otherwise I can't practice it, and you're correct. But let me do the math. So I'm taking the square root of the first, and I get x. I take the square root of the last, I get 6. If I multiply those together, I get 6x. Double that, I get 12x. That is indeed the middle term. So I have now verified for you this is a perfect square. And then let me undo that. So it is indeed a perfect square. Now, what is the answer? Just apply the shortcut, boom, and you're done. If you want to use Advanced Ninja Star, by all means, keep practicing that if you think that's what you're going to be using. But at least attempt once or twice the actual shortcut there. So people that I haven't called on. Okay, so it's going to be someone that I've called on twice. Let's go with Kira again.
Okay. Well, square root the first term, so I guess would it just be x?
It is, yep.
So x, and then square root the last is 6.
Perfect.
Then x times 6 times 2. So 6x times 2 equals 12x.
So it does indeed equal 12x. So you have now re-verified that it is indeed a perfect square.
Oh. And then I guess would it be 6x times, I don't know, 6x times 2 squared?
You have the answer right here. Remember, you took the square root of the x squared, you got x. You took the square root of 36, you got 6. Add those together and you're done, basically. And then you have to write it in a square.
6 plus x.
Yeah, so you can write it actually 2 ways. Yeah, you can do x plus 6, or you can do 6 plus x, and then that quantity, what?
Squared.
Squared, yeah. Both of those are the correct answer.
So if you want to just do it the fast way and just find your answer the fast way, you just square the first, square the last, and add them, and then square it.
Yes, exactly. Yeah, Jade, question.
Okay.
Okay. So we don't do basically anything with the middle number. Like in this case, the 12x. Like we don't do anything to it.
Yeah, you don't need to do anything to it. It's just there to verify that it is a perfect square. And I'm realizing now I've made a mistake in number 2. If anyone wants to catch that mistake in number 2, let's go with quiet raised hands. If you can find the mistake, I'm going to assume that anyone that has a quiet raised hand, you just get the extra credit.
Wait, but it's not a mistake because it just doesn't equal. It's not 8.
So I guess it's a mistake.
Was it meant to be a correct answer?
This is not a perfect square, and I need someone to tell me why that's not a perfect square.
Oh, can I tell you?
So Wyatt knows why it's not a perfect square. Charles knows why it's not a perfect square. I made a mistake in the notes. I should have changed that. So
I thought you meant to make it wrong.
I did not need to. I'll pretend I'm a good teacher. Yes, good job. You found the error, and I'm a good teacher because I meant you guys to find it. No, I totally made a mistake.
Well, there's also the whole back page, Mr.
The whole back page does work. I verified the back page. It's just you do GCF for some of them. Yeah, why?
That makes sense.
What
was the mistake for example number 2?
It's not factorable. So if you're gonna make it a perfect square, then if you square the first and the last, that's 1 and 7, or -7. So 1 times -7 is -7. -7 times 2, -14. That's not the middle. So it's not a perfect square and can't be factored.
Yeah, you're 100% correct. So I should have made this not a -7x, but what?
-14.
Yeah. So can we all change this to -14x so we can get some more practice? I'm thinking about leaving that mistake in there for next year because it's kind of fun to talk about. I love mistakes because that's how you learn. You really do. Yeah, but for the sake of our notes, let's go ahead and change this to a -14x. All right, so if I did change example number 2 to x squared -14x -49, what is the answer then? So another person that has, and if you had a quiet raised hand, so I think Jade, if you feel like you really knew that mistake, go ahead and give yourself the extra credit point. And then near the end of the year, when we're getting to the final exam, you guys can just take a picture of your extra credit tracker and send it to me.
I don't have mine.
Yeah, I don't have mine either. I left my folder at school.
Oh,
I think I got
you
3.
just use it.
I think I agree too.
You can use whatever. Yeah, Larissa, what's the answer to this one?
Would it be x minus 7 squared, parentheses squared?
Yeah, exactly. Yeah, done.
Oh, I see what it's minus.
So I do want to point out one thing about this problem, which is interesting to compare the two problems. This is not equal to 7 minus x quantity squared. Or is it? It's not. Okay.
Wait, so why is it not equal to 7 minus x squared?
Because, oh man, I think I made another mistake. I totally did, yeah. Dang, and it's a really hard mistake to understand. Because I'm like, in the back of my mind, I'm thinking, yes, it should be. Why is it not? This should be equivalent to 7 minus x quantity squared. But it's because I've made a mistake in a problem yet again, and I'm sorry for doing it. This should have been a plus. Man, super bad.
Okay.
Yeah, that last term is always squared. Anything squared is always positive. -7 times -7 should have been a positive 49. I made a mistake with my negatives. And that's what happens when you try to make an entire page of notes in like 5 minutes.
Plus, would that change the answer?
So I've made so many corrections out. The full problem that I should have written is x squared minus 14x plus 49. And the correct answer to that is the quantity of x minus 7 squared, which means that there's a mistake in future problems too. There's a mistake there. Oh my gosh. I've made 3 more mistakes. That last term should always be plus because it's a square. So if you're catching those.
Oh, well then you did make a mistake.
Yeah, like all of these need to be plus. Oh my gosh. So many mistakes. Plus. Okay,
Well,
now.
at least it'll be easy for us because we have like our paper to write on and erase stuff.
Okay.
Not me.
So.
Okay, yeah, sorry, Charles. Yeah, what question?
Sort of changed it all to plus though.
I'm confused about this part. If you make that positive 49, like it's a positive now, then 7 times 1 would be just 7, and 7 times 2 is 14, so you'd also have to make the 14 a positive, right?
So, yeah, you're talking about how to verify that it's a perfect square now?
Yeah, kind of. Like, how is it still negative 14 if it's a positive 7 times 2?
A positive 7. Yeah, so in terms of the shortcut, it doesn't matter the sign. So we can come up here and say the sign doesn't matter. The sign is only going to matter for this middle. When I use a shortcut, it will affect that middle number. But it doesn't matter in terms of our shortcut up here to understand how to use it. So say right here, sign doesn't matter.
Okay.
All right, let's try.
Would our answer be the same if it is a plus sign for the 49?
So if this, for example, in this problem right here, if I had this as a positive 14, it would have been a positive 7x or a positive right there. If I have a negative, then the sign in between here has to copy that sign and is also a negative. The middle term always dictates what the middle sign should be when you're writing your perfect square.
Okay.
All right. I'm sure a lot of you have moved on really fast, and that's totally okay. Please start Khan Academy if you finished the entire notes. Let's do example number 3. So we have a square. It tells us it's a perfect square, and it has an area that I corrected. It should be x squared minus 18x plus 81. it has a width or a side length of x minus 9. What is the other side length that I'm trying to find here? And it's a perfect square, so you don't even need to like look at this. Just knowing that it's a perfect square, this length and this length should be the same. That's the definition of a square. So we'll give this to someone that hasn't participated yet. Who have I not called on yet today? I have not called on Eamon yet today. So Eamon, do you want to do this one?
Yeah, I'd like to do it. The square below has an area of x. What expression represents the length of the square? The side length is 9x. I mean, it looks like the other one should be something 2x, but that doesn't seem right either. It seems like it's either.
If you have x minus 9 and it's a square, that means this length and this length must be the same length.
Okay, so that means that is x minus 9.
Exactly, x minus 9. And we can verify that by multiplying out x minus 9 times x minus 9, and we will get x squared minus 18x plus 81. If you want, you can FOIL it out and check that. Kira, question. And you should probably unmute yourself. Kira, did you have a question? Oh my gosh. I'm trying to hit buttons and we hit them at the same time.
Oh, there we go. Okay. So when you write 6 plus x squared, does that mean 6 plus x times 6 minus x?
No, so 6 plus x squared means it's 6 plus x times 6 plus x.
Okay. Then this one we're working on right now, you couldn't do squared. You couldn't write squared.
For example number 3?
Yeah.
Right, yeah, because we don't want to write x minus 9 squared. I mean, if I want to find this area, I am essentially doing x minus 9 quantity squared, but the question is just asking us what is one of the side lengths. It's not asking for both of the side lengths because it already gave us one of them.
So, Mr. Personnel, that would be our answer, x minus 9 squared. That's what we would put in the con.
In Khan Academy, whenever you see these side lengths questions, you're just going to write the other side length of x minus 9.
Okay.
Yeah, I got one wrong because of that.
And then also, what was I gonna ask? Oh, how do you decide if it's to put a plus or a minus?
So you always copy down the sign that's that middle term. If that middle term is a minus, then the middle sign, I should say, is a minus. If this middle term is a plus, then the middle sign is a plus.
Okay.
All right, so we have only 4 minutes left, which means I kind of have to rush through the final 3 examples. So sorry, I can't ask for participation. I'm just going to go through it as slow as I possibly can, but I'm going to go through all of these. Okay, so again, our first step is always GCF. Does this problem have a greatest common factor? Well, between 9 and 4, there is no greatest common factor. So step 1, done. Step 2, I can use either advanced ninja star or the shortcut method. Let me verify that I can use the shortcut method. Square root of this one, I get 3x. Square root of this one, I get 2. 2 times 3x is 6x. Oh my gosh, did I make another mistake?
Yeah, I saw that.
This should be a 12. Wow, I'm making way too many mistakes today. I guess I need to do this the night before instead of the morning of. Let's change this problem to 12x so it does work out, and then we can write out our final answer as 3x plus 2, or 3x minus 2. Sorry, I have to copy down this minus sign in between. So 3x minus 2 quantity squared. And there's the final answer that I would type into Khan Academy.
Wait,
So it's not 24.
no, it's
12x.
it is. Wait, I made it work for 24 because the 3 times 2 equals 12x, and then 12x times 2 is 24x.
I think I made the same mistake in my head too, but 3 times 2 is 6, not 12.
Oh yeah,
Yeah,
I meant 3 times 4 on that one.
yeah. These little mistakes. I'm sorry. Okay. Example number 5. You'll immediately notice, hey, 75 is not a square. If I try doing those steps of taking the square root, it doesn't work. So I have to factor out the greatest common factor. In this case, It's 3. 3 goes into 30. It goes into 3. And there are 3, if I have quarters, like change, 3 quarters is 75 cents. So 3 also goes there. So if I factor out the greatest common factor of 3, then I'm left with 25 because each of them is a quarter. So it's 25x squared minus 10x plus 1. Okay, let me verify that this is a perfect square. I'm going to take the square root of the first, and I get 5x. Square root of the last, I get 1. Okay, finally, I get 1. 5x times 1 is 5x. I double that, and I get 10x. So my final answer is 3 times the quantity of 5x minus 1 squared. And I have 1.5 minutes left, so I have to unfortunately move on to example number 6. Again, I can't take the square root of 72, so something weird must be happening here. This one, I have to factor out the greatest common factor. Let's see, 2 works because these are all even. 3 doesn't work. 4, does 4 go into 72?
About 8.
And 8 goes into, 8 goes into all of them as well. Yeah, so this is going to be 8 times, and then it's going to be 9x squared plus, and then 24 divided by 8 is 4x plus 1.
Oh, error, Mr. Sindel.
Yeah, there's an error.
It's plus 3x, right?
It is plus 3x. Yeah,
Not 4x.
thank you. Like, what's going on there? Okay, now it should work. And, gosh. I forgot
It's okay, Mr. Sindel.
Oh my gosh. Is that a mistake in almost every other problem?
Uh-huh.
Let's change that to a 48x, and then it works out. So that makes this a 3, changing into a 6, and now it works. Sorry, guys. Man, I feel really bad. I will do better. I promise.
It works if
better.
you use 2, but I guess that's not the GCF.
All right. So if I change that to a 48x, 48 divided by 8 is 6. And now this is going to be, if I square the first, I get 3x. If I square the last, I get 1. 3x times 1 is 3x. Double that, I get 6x. It is indeed a perfect square. So the answer here is 8 times 3x. Copy down the sign, which is plus 1 squared. So guys, that's all you have for today. I'll leave this open for another few minutes, but you do have to move on to your second period class.
Okay, thank you, Mr.
Yeah, bye,
Sindel.
Mr. Sindel.
Yes.
Farewell.
Mm.